Hi everyone, welcome back to Lulumath. This video is on factoring a difference of perfect squares. And before we watch this video, make sure that you have the background knowledge that you need, which is how to factor a trinomial. And if you need a refresher on how to factor a trinomial, make sure to check out those videos at lulumath.com or on the Lulumath YouTube channel. So in this first example, we're asked to expand 2x plus 5 multiplied by 2x minus 5. Now don't forget that when we're factoring, we're undoing this expansion. So I want to do this expansion so we can see how the factoring is related to the actual expansion itself. So if you remember, we're going to multiply 2x by 2x and we end up getting 4x squared. Then we will multiply this 2x by this negative 5. And when I multiply those together, I get negative 10x. Next, I will multiply 5 by 2x and I end up getting 10x again. And then the last thing I'm going to multiply is 5 by negative 5 and I get negative 25. Now remember, we always collect our like terms. So our like terms here are this negative 10x and this positive 10x. But because they are the exact same coefficients, except one is positive and one is negative, they will cancel each other out. I have 0 x's left over, so I don't even have to write that x down. My final answer is 4x squared minus this 25 right here. Now notice that the reason why the outer here and the inner canceled each other out is because we have 2x multiplied by a negative 5 here, and then we have 2x multiplied by a positive 5 here. So in order for them to cancel out, these binomials have to be almost identical, except one has to be a plus and one has to be a minus. And that is what makes the difference of perfect squares a difference of perfect squares. So there are 3 conditions or 3 criteria that you need in order to identify if an expression is a difference of perfect squares. The first condition is that the expression has to be a binomial. So just a reminder, binomial means it has 2 terms. So if you look here, the 4x squared is one term and then 25 is the other term. The negative 25 is the other term. The next criteria is that it must be difference. It needs to be subtraction. So if you see here, this has to have a minus sign here. And if you remember, we said because this has to be plus and this has to be negative, when we multiply our lasts together, we end up getting a positive times a negative, which is a negative. And that is why we have to have a difference, or why we have to have subtraction. The last condition is that both terms have to be perfect squares. So our first term here, this 4x squared, is a perfect square. And the reason why it's a perfect square is because when we multiplied this 2x by this 2x, they were identical. So they will be a perfect square because you're multiplying a term by itself. And our last term is a perfect square as well, because again, when we do our last terms multiplied together, they're identical. So you will end up getting a perfect square. Okay, in our next example that we have here, we're asked to factor x squared minus 49. Now we need to determine, is this expression even a difference of perfect squares? Well, let's look at our 3 conditions. Our first condition is that it has to be a binomial, so it has to have 2 terms. And x squared and minus 49, we have 2 different terms, so it is a binomial. So we can put a check and say, yes, our first condition is satisfied. The next condition is there has to be a difference. There has to be subtraction. And here we do have a subtraction sign, so it is a difference of 2 terms. Again, we can check this off. And then lastly, we have to have perfect squares. So let's see if they're perfect squares. So I'm going to take my first term, which is x squared, and I'm going to see, can I square root x squared? And yes, I can. The square root of x squared is x because x times x is x squared, okay? Then I will take my second term, which is this 49, and I'm going to see, can I square root 49? And yes, I can. And the reason why I can is because 7 times 7 is equal to 49. So when I set up my binomial multiplied by my binomial, I know that this x right here is going to be my first term in both binomials. And then I also know that this 7 here is going to be my second term or my last term in both binomials. The nice thing about factoring differences of perfect squares is that once you can identify that they're differences of perfect squares, it's so easy to factor. So normally what we would do is we would do a little bit of guessing and checking, but we don't have to do that when we have a difference of perfect squares. I'm going to do it in this example so we can see how doing the guessing and checking will show us that it actually works for us. So my outer right here, x times 7 is 7x. And then for my inner, I would do 7 times x, which is also 7x. And notice how there is no x term, no x to the power of 1 here. And I can get no x term here because 7x and 7x can cancel each other out if one of these is positive and the other one is negative. Well, if this 7x here is positive, that tells us that this 7 over here is also positive. And if this 7x here is negative, then that tells us that this 7 over here is also negative. But again, the nice thing about a difference of perfect squares is once you've satisfied all 3 conditions, then all you have to do is take the square root of your first term, take the square root of your last term, have a plus and a minus, and it will always work as long as you are 100% sure that it is a difference of perfect squares. So in our next example, we have 25x to the power of 4 minus 36y to the power of 6. And I want to see, is this going to be a difference of perfect squares? So let's look at our conditions. Our first condition is that it has to be a binomial. Well, here we have 2 different terms. So our first condition is satisfied. Our second condition is that it has to be a difference, that there has to be subtraction. So looking here, we have subtraction. So our second condition is also satisfied. And then our third condition is that we have to have perfect squares. So let's see. Well, our first term is 25x to the power of 4. And I'm going to see, can I take the square root of that term? Well, I can because the square root of 25 is just 5. 5 times 5 is 25. And x to the power of 4, what multiplied by itself can give me x to the power of 4? I could do x squared. And the reason why this works is because 5x squared times 5x squared gives us 25x to the power of 4, because when we multiply, don't forget that we always add our exponents. Now let's take our second term here and see if we can square root that. So I will take 36y to the power of 6 and see, can I square root that? Well, the square root of 36 is 6. And then what multiplied by itself will give me y to the power of 6? Well, if I have y to the power of 3 times y to the power of 3, remember, again, if you add these exponents together, you'll get that y to the power of 6 that we're looking for. So 6 times 6 is 36. So we get 36y to the power of 6. So a quick note here is that if you want to find the square root of a term with an exponent, simply cut the exponent in half. So for example, here we have x to the power of 4. Half of 4 is 2. The reason why this works is because if I were to multiply something with an exponent by itself, there's 2 of them to get to this x to the power of 4. So since there's 2 of them, to split it evenly, I have to cut it in half. Same thing here, y to the power of 6, I gotta split it up evenly. So half of 6 is 3, and that's why this works. So let's go ahead and get our binomials ready to go. The square root of 25x to the power of 4, we figured out was this 5x squared that we have here. So we can put 5x squared as our first terms in both binomials. And then to find the square root of this 36y to the power of 6, we said it was 6y to the power of 3. So we can put 6y to the power of 3 here and 6y to the power of 3 here. Remember, in order to get this negative here and to get our middle term to completely cancel out, then one of my 6y to the power of 3's has to be positive and the other one has to be negative. And this is my final answer. Now, really quickly, I just want to do a quick check on this, and I'm going to do my outer and my inner just to see what happens. But again, we don't have to do guessing and checking when we identify that something is going to be a difference of perfect squares. So for my outer, 5x squared times negative 6y to the power of 3, 5 times negative 6 is negative 30, and then x squared y to the power of 3 is just x squared y to the power of 3. For my inner, 6y to the power of 3 times 5x squared, 6 times 5 is 30, and then we have x squared, and then y to the power of 3. Again, order does not matter when we are multiplying. So this 30x squared y cubed and this negative 30x squared y cubed cancel each other out, which is exactly what I'm hoping would end up happening. So that means this right here will be my final answer. So in this next example, x to the power of 8 minus 16, I want to see, is this going to be a difference of perfect squares? Because again, if it is, then it makes things so much easier when we're factoring. First thing I'm going to see is this a binomial? Yes, it is, because we have two terms. Check. Next thing I'm going to do is look and see, is this a difference? Is there subtraction? And yes, there is. So again, check, this works for us. Lastly, I'm going to see, do I have perfect squares here? So I have x to the power of 8, and I'm going to square root it, and the square root of that is x to the power of 4, because x to the power of 4 times x to the power of 4 is x to the power of 8. And then my other term is this 16 here, and the square root of 16 is 4. Again, our goal is to just be able to quickly do the factoring without having to write anything out or do any extra work. Let's go to our binomial here, multiplied by our binomial. We know that our first term in each binomial is going to be x to the power of 4 based on what we did right here. And we know our second term is going to be a 4 for both binomials, except one is positive and one is negative. Now, normally we would say, oh, we're done. We finished this. We factored everything. However, take a very close look at this binomial that we have here, this x to the power of 4 minus 4. If you notice, it is a binomial that has two terms. It has a subtraction sign in between our two terms, and we also have some perfect squares. So I will factor this binomial as a difference of perfect squares. This time, I'm not going to write anything out. I'm just going to try to do it quickly because, again, the goal is to quickly do this factoring once we understand what we're doing. So x to the power of 4, the square root of it is x squared. So I'm going to have x squared and x squared. And then for this 4 right here, the square root of 4 is 2. So I'm going to have plus 2 and minus 2. And then I have factored this difference of perfect squares binomial that we have here. Now for our first binomial that we see here, however, this is not a difference of perfect squares because there's addition and not subtraction. And it has to have subtraction in order for it to work for us. So here I will just copy down this x to the power of 4 plus 4, and we will say that this is our final answer. Now, like we said before, factoring a difference of perfect squares is pretty straightforward. However, it's easy to make a mistake and think something might be a difference of perfect squares when it's not. So I actually want to take a look at a couple of non-examples of a difference of perfect squares so we don't accidentally factor these types of examples as differences of perfect squares. So just a reminder that there are 3 conditions in order for us to have a difference of perfect squares. The first condition is we have to have a binomial, which we do. We have 2 terms here. So that condition is satisfied. The next condition is it has to be a difference. There has to be subtraction, and we don't have subtraction. So our second condition is not satisfied. And then our last condition is we have to have perfect squares. So this right here is not going to be factorable. There is a separate video on why you can't factor a sum of perfect squares. This is one of the most common mistakes that people will make when they're trying to factor. So it's really important to make sure that you check that video out if you need a deeper understanding as to why you can't factor these types of examples that we have here. Our last non-example that we have is 64x to the power of 3 minus 100. So let's look at all of our conditions. Our first condition is we have to have a binomial. And we do have a binomial. We have 2 different terms. Our second condition is we have to have a difference. We have to have subtraction, which we do have, okay? But our last condition says that we have to have perfect squares. And although I can square root the 64, I cannot take the square root of x to the power of 3 because I can't divide this x to the power of 3 into 2 identical monomials with integer exponents that will multiply together to give me x to the power of 3. So for example, I could do x to the power of 2 and x. Those will multiply together to give me x to the power of 3, but they're not identical. So there's no possible way that I can take the square root of x to the power of 3. Now, let's say I were to actually try to factor it. Let's say I were to take the square root of 64 like we usually would do, and that is 8. And let's say I were to put an x squared here and an x here. Okay, and now let's also take the square root of 100, which is 10. So I would have a positive 10 and I would have a negative 10. If I were to do the outer right here, 8x squared times negative 10 is negative 80x squared. Then if I were to do the inner here, 10 times 8x is 80x. So because these are not like terms, they can't even be put together, let alone be able to cancel each other out. So there's just no possible way to factor this as well. Okay, that's it for this video. Thank you for watching. If you have any questions, please let me know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If you found this video to be helpful, please don't forget to subscribe and share with others. Have a great day, and we'll catch you next time. Bye.